Alrighty then, going on now to example number 6. We're going to solve a distance, rate, and time problem. Okay, so here we go. We have a small fishing boat that travels at 36 miles against the current in a river, and at that same time that it travels to 44 miles with the current. So it's going to go against the current and with the current using the same time. Now, if the rate of the boat in still water is 20 miles per hour, find the rate of the current. All right, so when thinking about stuff like this, I've always found these kind of problems very helpful to use a chart. Okay, and that's what I want to kind of do here, and I kind of do this, that's not what I like. So let's see, I'm going to do I want a distance, rate, a distance and a rate and a time kind of column right here. So I'm going to there and there. That should probably do it, I think, there. So let's see. So usually I have my distance, right, equals rate multiplied by time, right, dirt. And then right here, I'm going to have my two categories, which let me just read through this again here so we can get this. All right, so a small fishing boat travels at 36 miles against the current in a river in the same time that it travels 44 miles with the current. All right, and if the rate of the boat is in still water is 20 miles per hour, find the rate of the current. All right, great. So our distance here, right, is 36 and 44. So maybe we have one that's with the current, and then we have against the current. Okay, because we have going up through the river and down the river, or against the current and then with the current. All right, great. So with the current, let's see, it said, or against it, it said it traveled at 36 miles, all right? So against it, so 36 miles. So see my distance against the current, 36 miles. Put miles right there. And then with the current right here was 44 miles. Okay, so that's nice. But it also says find the rate of the current. So that's what we want to let x equal the current. Okay, so that's what we're going to do right there. That's current, and that is in miles per hour here. Okay, so that's what x equals is the current here. So check this out. If you want to know what the current is, right here, it says that the boat in still water travels at 20 miles per hour. So that means the rate, okay, watch this, with the current, so just by sitting there it's 20 miles per hour, but since it's with the current, you're going to add the current, right? Does that kind of make sense? So I'm going to add whatever the current is, that's going to make my speed faster. And then here, I'm going to take my current speed by in still water, but now I'm going to go against it, so subtract the current there. Okay, so that's my rate. All right, and then my time. Now it says it's the same time, so we don't exactly know what it is, but check this out right here. Remember how we said from our formula up here, distance equals rate multiplied by time. So we can actually solve for t, divide both sides by r, and t would be equal to distance over rate. Right, so that's what t is. So actually that's what we can do right here, is we could just go ahead and my t here is my distance over my rate. So it's 44 over 20 plus 4. Oh, I'm sorry, 20 plus x. And the same thing right here, distance over rate, 36 over 20 minus x. Okay, and that's what it says right here. It says that in the same time. So basically these two should be set equal to each other, because when it travels with the current or against the current, it's the exact same time. So we should be able, so from that information, this is why this was very important here, we can use this information by setting these equal to each other, because it says that they traveled at the exact same time. All right, so 44 over 20 plus x is equal to 36 over 20 minus x. All right, great. So we're ready to solve this bad boy. And since we have fractions here and all that, what do we want to do here? First, let's go ahead and actually just cross multiply. Since we have a fraction equals a fraction, right? We could just go ahead and cross multiply. So multiply those guys right there and then multiply those guys, all right? So I'm going to cross multiply this right here. 44 times 20 minus x, and then 36 times this guy. 36 times 20 plus x. Sweet. So if I distribute this 44, let's see, I'll get 880 minus 44x. Distribute this 36, and I'll get 720 plus 36x. I'm going to solve for x here, so I'm going to, let's see, subtract 720 from both sides. And so I'll get, what's that, 1? I'll just do kind of both here, and then I'll add 44x. Add 44x. I'll just kind of just do it all at once. So I get 160 is equal to 80x. Divide by 80, and voila, we get 2. 2 what? Like, what does that even mean? Well, we go back up here, like, what does x even represent? X is the current in miles per hour. So we just said that the current is 2 miles per hour. Okay, so that's what we just found out now. Find the rate of the current. And there it is, 2 miles per hour.